Okay, this is a supplemental lecture related to IPv4 addressing, and what it covers is messaging types. What I mean by that is often related to the destination of IP messages. For example, the first one to talk about is Unicast, which is one-to-one messaging. So you have one source and one destination. The other type we can have, or one of the other types we can have, is broadcast, which is one-to-all messaging. And the reason all is in quotes is because all is all the devices that are on the same network as the sender. And then finally we have multicast, which is one-to-many. The example I do, or the discussion I have if I'm in the classroom, is this. You know, a unicast message, one-to-one messaging, would be like, hey Cindy, can I see you after class? So I'm the sender, the receiver is Cindy, or the message is destined for Cindy. And we've talked about this in IP addressing. Obviously the whole class hears that, but everybody other than Cindy ignores that message. A broadcast would be something like, hey everyone, don't forget you need to complete your homework before next class. So that is sent out to all the students that are in the classroom. Multicast is one-to-many, and I guess that would be something like I would have a class and I would say, hey, everyone that's a freshman, here's an announcement for you. So that would be destined for all the freshmen in the classroom, so a subset of the people that are in the class. We'll go through these kind of like the example when I ask you what type of IP address we have. There's different ways to look at it. Is it private or public? The other way to look at it is it a network number? Is it a broadcast address? Or if it's is it a host? So kind of in that scenario, we check and see if it's a network number. Then we check to see if it's a broadcast. And if it's not, then it's a host. So the same thing kind of applies to kind of figuring out what type of message type we have. So as I said before, a broadcast is one-to-all messaging, with all meaning all devices on the local network. And the way we tell if something is a host address, you know, I would ask this question and expect the students to hopefully answer pretty quick, that a broadcast address is an address that has all of its bits set to 1. So you look at a message type, divide it into a network and a host portion, and if all the bits in the host portion is 1, then we're looking at a broadcast message. A couple of related topics that should be reviewed is what is a collision domain and what is a broadcast domain. So a collision domain is a collection of all the machines that are possible of experiencing a collision with each other. And then we talk about devices that either segment or isolate domains, or ones that expand it. And in the case of a collision domain, since that is a physical thing, routers and switches both segment collision domains. So that's kind of just a review topic. The main thing I want to talk about is a broadcast domain. So a broadcast domain is if a machine sends a broadcast message, it is a collection of all the machines that are able to see that broadcast message. In the case of broadcast domains, switches will extend the broadcast domain. Another way to say that is broadcast messages will pass through a switch. However, routers segment broadcast domain, so your broadcast domain ends at the router. In the case of multicast, this is one-to-many. And like I said, this would be a subset of the devices on the local network. Basically what we do is we have multicast groups that look like an IP. This is the range of multicast addresses, and the chosen IP is referred to as a multicast group. And then all the machines that need to hear the message for that multicast group listen for them. They specify what multicast group or groups they're listening for. One example I can think of as multicast is there's a piece of software called Ghost, which is intended for imaging Windows machines. And a lot of times in the lab environment, we'll set the teacher station to send out the multicast message, and we'll set all the machines in the classroom or the lab to listen for that multicast group. And then basically the sender says, okay, here comes your image that you need to put on yourself. And it sends the message out once, but all the machines, let's say 24 of them in the room, receive that multicast message and image their machines. So that's a discussion on Unicast, broadcast, and multicast, again related to IP version 4. The reason I stress that is IP version 6 is similar, but their broadcast has changed.